Assalamualaikum and hi everyone. Today we are going to present on the comparison of methane and also iso-octane fuel molecules using Gaussian. So to introduce both molecules, methane and also iso-octane fuel is both considered as hydrocarbon fuels, where it is an organic compound which contains only carbon and also hydrogen atoms. Both hydrocarbon fuels also is widely used as energy sources, and the molecular structure of these molecules will influence its physical state, volatility, and also fuel application. For methane, the atoms will be CH4, while iso-octane is C8 and H18. So why do we need to compare them? Methane is a small molecule where it is gas at room temperature and also considered as natural gas, while iso-octane is large and branch molecule which is liquid at room temperature, and the application of iso-octane is in gasoline. So the purpose of us comparing these both two molecules is we want to compare its molecular geometry, size, optimize energy, and relate it to structure to fuel application. So the method that we use to compare is using Gaussview, where we would first draw the methane molecule and also iso-octane molecule, and next is to verify whether it is correct molecular structure or not, and we will save it in Gaussian input file. So in geometry optimization, these are the softwares that we use as parameters. For example, job type, method, basis set, and others. And then also for our setting, we use Gaussian geometry optimization to optimize the molecules, and also HF321G and others. So why do we use HF321G? Because it is a simple and computationally efficient. Also, it is suitable for introductory molecular modeling and produces optimized molecular geometry. So for methane, the first column is the structure before optimization, and the second column is for after optimization. So we can see the difference in three criteria, which is bond length, angles, and also energy state. For bond length, before optimization, it is 1.07 to 1.1, while after optimization, it is 1.08, which is increasing. Second of all is the angle, where before optimization, it is a tetrahedral geometry with potentially strained or imperfect, and also the after optimization, it is perfectly symmetry with HCH angles locked precisely at 109.47 degree. As for the energy state, before optimization, methane higher unrelaxed total electronic energy on the potential energy surface, while after optimization, the potential energy has already been minimized with all forces and displacement converged to zero. Next, we are going to move on to iso-octane. So as usual, the first column is before optimization and the second column is after optimization. So in bond length, 1.07 until 1.54. For after optimization, it's 1.08 to 1.54. For angles, before optimization, it is a straight symmetry with CCC angles at 109.47 degree, while in after optimization, it is perfect 3D symmetry with CCCC angles locked precisely at 108.8 degree. For energy state, we have higher potential energy and less stable structure before optimization, and after optimization, we achieve lower potential energy and a more stable structure with minimized atomic forces. So this is the basic geometry analysis and comparison table. Molecular formula, where we compare molecular formula, and the observation also simple interpretation. And then next is the discussion and conclusion. So for this, for the discussion, we found out that methane is small, so it will have weak IMF forces and exist as gas, while iso-octane is larger and branch, so it will have stronger IMF and it exists as liquid. So this will show that molecular size and shape will influence volatility, physical state and also its fuel application. So to summarize this up, methane and octane were successfully built and optimized using Gaussian, as I have explained earlier. While methane remained as tetrahedral, iso-octane formed a large branch structure. So these results show that molecular structure will help to explain the different behavior and application of those two fuels. So this is all from us. Thank you.